Salam Sejahtera, Guten Tag. The German Academic Exchange Services DAAD is very appreciative to collaborate with the Faculty of Mechanical Engineering at Universiti Teknologi Malaysia in organizing the World Congress on Science, Engineering and Technology. WCOSET 2021 is the inaugural congress that hosts 6 conferences encompassing the wide-ranging areas of intelligent systems, robotics, medical engineering, aerospace, manufacturing technology, and engineering education. It is a delight for us at DAAD to be informed that almost half of the papers contributed to the conferences are co-authored by research collaborators outside Malaysia. This kind of scholarly networking is fully in line with the aspirations of DAAD in promoting cross-border academic exchange for the greater benefits of science and technology. We hope this Congress will be a catalyst to new collaborations, and we are certain that it will help strengthening existing ties. On behalf of the DAAD, I would like to express my sincere gratitude to the Faculty of Mechanical Engineering at UiTM for pioneering this unique, groundbreaking and visionary event. Thank you. Thank you very much.
My sincere appreciation to all the keynote speakers, presenters, and participants from local and international organizations who have given their commitment to attend and make this International Congress a success despite challenges posed by the COVID-19 pandemic. No doubt, COVID-19 has disrupted every aspect of our livelihood. However, the severity of the disruption has made us realize the importance of being resilient, flexible, and adaptable to the new norm in these challenging times. Ladies and gentlemen, today's event is another groundbreaking initiative led by the Faculty of Mechanical Engineering and Smart Manufacturing Research Institute to bring together researchers, academicians, students, engineers, and practitioners to bridge gaps and share latest research findings, ideas, current developments, and applications related to various aspects of mechanical engineering with emphasis in science and technology. This event will serve as a platform to gather and disseminate knowledge as well as pioneering innovations for benefit of all. I foresee that this intellectual discourse will result in future collaborations between universities, research institutions, and industries, both locally and internationally. Ladies and gentlemen, glancing through the 6 conference tracks of the Congress reveals the amazing diversity of mechanical engineering-related fields. They range from robotics and intelligent systems to aviation technology, biomechanics, medical engineering, quality management, advanced material, and sustainable energy. Developments in the field of mechanical engineering have always continued to take place. Throughout history, there is no doubt that the development of mechanics has contributed to the betterment of different aspects of our daily life. With Industrial Revolution 4.0 upon us, we are witnessing an integration of automation and data analytics that allows for higher flexibility as well as more efficiency in improving quality of our lives. Thus, there is a great need to capitalize on the advances in technology and engineering knowledge to produce even more game-changing breakthroughs. Here at the university, we remain committed to support initiatives that bring forth impactful advancement in academic excellence and cutting-edge technologies. Through this Congress, we shall all look forward to partners in academia and the industry to actively strategize, explore, and share technology advancements. For new innovations to occur, it cannot take place in isolation. We need to work together through interdisciplinary collaborations. Looking ahead, I am confident that through all our efforts, we will be able to achieve more. Finally, I would like to congratulate the Faculty of Mechanical Engineering, UiTM, for their ceaseless effort and hard work towards organizing this event. Your enthusiasm in contributing and achieving more in the field of science and technology is commendable and very much appreciated. Last but not least, I wish all of you a successful, productive, and interactive virtual time ahead. And may this International Congress be the beginning of many new friendships and partnerships that will flourish in a much more significant way. On that note, ladies and gentlemen, in the name of Almighty Allah, most beneficent, most merciful, I humbly officially launch the World Congress on Science, Engineering and Technology 2021. Thank you very much for listening. Assalamualaikum warahmatullahi wabarakatuh.
So additional to what Dr. David said, that I'm responsible for digital transformation within Hexagon Manufacturing Intelligent and the CEO of Simufact. I also found the company Simufact Engineering, which is meanwhile part of Hexagon Manufacturing Intelligent. I want to give you a quick overview about Hexagon, who we are. So we are nearly 4,000 employees in R&D. We are 20,000 employees nearly across the whole world, and we have made 4 billion euro revenue nearly in 2019. This should be enough. Important is also because we have owned factories, we are also in the area of metrology. So we have found a new company, Revolution, because at the end, I think this is the intention from everybody of us, is we need to save our planet. Everything what we are doing need to be sustainable. We need to increase the productivity and quality. And at the end, this means by using the right technology to save also our environment. And this is the driver for us. What is our understanding about smart manufacturing? It will start in an early stage from design. So design the right product with the right manufacturing process at concept, then orchestra perfect quality and minimize waste production. This is only possible if we are continuously learning and adapting quickly to changing the conditions in real time. So first of all, this means that it's a interdisciplinary work. We need to connect all information which we will have, leverage them, analyze them to drive decisions. And I know that all of this is also a driver in the different disciplines, but at the end, we can make it much, much more efficient if we are bringing all together. So when we are looking Hexagon Manufacturing Intelligence, which is part of the full Hexagon, concentrating on the manufacturing area with 8,000 people, we are focusing on the design and engineering area, production area with GATCAM, the metrology side, inspection, and the software behind this. And a big driver is digital transformation. Because at the end, we have to bring everything together. We have to connect people, as we are doing here now in this nice conference, and also the technology. If we are looking, what is the main driver for the industry? Why do we need to increase productivity and the quality? In principle, we have a generation shift. So it's time for effectiveness for new stuff. They will not have the time to learn fast, or they have to learn fast. They don't have the time to learn it, and they have a different skill set. So we need to provide the right tools and to accelerate the overall experience from the new people. We have pressure on productivity. Based on the economic slowdown, what we are realizing at the moment in the COVID-19, but also overall, we need to be very, very flexible in response to trade tensions. Sustainability, what I mentioned, is a driver. Also, the industry will switch more and more to electrification. Cloud systems, so XaaS, platform as a service, software as a service. and the software utilization across all the industries. The consumer expectations are driving the development, the competitive pressure and time to market shrinking. Remote productivity, collaborative work and light outs, especially with the homework, with flexible fabrication, where we can do it, with the logistics behind this. So all of this has an influence on the future industrialization. And where are we working on? Hyperconnectivity, analytics, technology progress. But at the end, there are so many activities, we have to bring the things together. But where to start from? So we have made a survey last year to find out what are the companies expecting from Industry 4.0. They want to compile and leverage data to obtain insights into design and manufacturing that impact the quality and productivity. They are looking for more integrated systems, engineering and the shop floor to provide methods that can help to take decisions. At the end, everything is driven from decisions. We are using the tools to get a view inside the process. We want to make decisions. So here we need to provide a better form of doing this very, very fast based on all information what we can use. Also, they are looking more and more to implement only solutions which can solve problems today with a short ROI and even is sustainable for the future. And we need to optimize it in a way to say, in the virtual world, I want to optimize my inspection plan, and then I will execute it and even feed back the information. So also the software here need to be linked in the virtual world and then during the production and measurements. When we have all the data, and in production, we have a lot of historical data. So not everything is the same. We need to analyze it. We can use statistical methods. We can use AI. And at the end, what we want to achieve is a real-time analysis. So be very, very fast. But this means first to have the data, and then we can visualize it easily in real time. But to make it really intelligent, smart, we need to have artificial intelligence algorithms, machine learning algorithms, where we then can reflect better all the dependencies and drive decision and show trends. I will show you one slide at the end later. All experience what we get in every stage to enable decisions and to use it later for AI. When we do this right, then we can achieve a lot. And this is a summarized slide at the end. And then I also want to thank Jupiter Manrun that you invite me here together with the committee to give this keynote. And Jupiter Manrun is our specialist for smart manufacturing and for the products from Simufact in the South Asia regions. And he has a lot of experience already in his institute with his people and the students. So thank you very much. I will hand it over to Dr. David.
And Dr. Hendrik, if I'm not mistaken, mentioned about 3 types of digital twin. Digital twin in form of the design, manufacturing, as well as maintenance, I think. I think it's very the way forward in terms of the smart manufacturing. How long it takes us, perhaps, in your opinion, Dr. Hendrik, to realize all these three digital twin? I think the digital twin in terms of a design, I think is quite well established, I think. But how about this? Another thing about this manufacturing and also this about the maintenance part. Can I get your opinion about that? Thank you, Dr. Hendrik.
Okay, I think, to be honest, it will take 30 years or more. But in some areas, we are very far. That's what I said, in additive. In the area, if we are thinking about autonomous driving, we also have a lot already.
double PhD now, and I'm a professor of Bauman Moscow State Technical University. The University of Bauman is a public technical university, is a polytechnic university located in Moscow, and it is the oldest and the largest Russian technical universities that offering bachelor student, master student, PhD degrees in various. Today, pipeline transport in Russia is a platform for implementing many unique techniques and technological solutions aimed to ensure the safe operation of pipelines, reducing oil transportation costs and the scale of possible incidents and accidents. More than 50% of the volume of the total number of oil products is transported through trunk pipelines. Russian Federation now is one of the main exporters of oil and gas, and due to geographic peculiarities, as you can see here on the map, so due to these peculiarities of the production region, it has an extensive trunk pipeline network functioning since the beginning of the 20th century. Despite all the measures taken to improve the reliability of the pipeline network operation, its accident rate is not decreasing as fast as it is necessary to ensure the environmental safety. Accelerating climate changes, forcing of oil pumping and pumping regimes lead to the imbalance in the system that I present, the system of ground, climate, and pipeline. This is the system that I will show you later. So all these things contributes to a relevance of my research. Natural technical linear pipeline systems such as mine have specific features that must be taken into account when we organizing the monitoring of the geological environment of the territories in which they are located. Among them, significant length of pipeline routes, trends in the increase in technological loads on pipeline associated with the increase in the volume of pumped products, extremely serious environmental consequences in case of accidents or incidents, and the coordination of various pipeline structures with engineering complexes of developed accumulations. According to the European statistic, the number of accidents from natural influence is 4 to 9% for gas pipelines and 3 to 5% for oil pipeline assessment, and provide organizational measures. We'll start from requirements, and when we consider each section of the pipelines with the adjacent territory, ground thickness, surface, local facilities, and climate is considered as a single system, all significant states of which can be described by a set of measurement parameters. So our requirements for monitoring means that we set are here. So far, our digest perspectives are these. The next step in our research is to develop a digital twin of the system. During all these years, what we have done is we used the systematic approach in our studies. We consider firstly the intersection, the interconnection of medias of ground, climate, and pipeline. This is a new approach. So if we will do our digital twin, we could implement it because we have some places where we can implement our system. So I would like to thank the organizing committee for the opportunity to present at the conference, to be a keynote speaker. Also my colleagues from Bauman University, from University of Genoa, and as well as Extreme Situation Research Center that helps us with our visual survey that is very difficult using a helicopter. So thank you very much.
I hope we can meet face to face later on, and I hope that this is the initial stage for us for further collaboration. There's comment, no question, Dr. David.
All right.
Thank you.